Do you still think high-end semiconductors and automotive-grade hardware are entirely controlled by overseas brands? Do you still believe global giants hold all the core technology, leaving every other manufacturer only room to copy and follow? After walking through the entire 2026 Global Electronics Expo in person, I can tell you straight that old industry mindset is no longer valid at all. Today, we're going to do a real, no-filter deep dive. No clickbait, no shallow surface-level talk. I'm going to walk you through the actual technical gaps, the hidden strengths, and the real limitations between top global brands and rising domestic manufacturers. We'll go through power semiconductors, MEMS sensors, automotive chips, PCB manufacturing processes, isolation solutions, and the entire hardware tech stack. I'll show you what's overhyped in this industry, where the real breakthroughs are happening, and exactly which trends will dominate the market over the next 2 years. Everything you'll hear in this video comes directly from on-site booth observations, official product datasheets, and first-hand technical documents from the Expo. I've divided this video into 2 straightforward parts: in-depth technical analysis and practical industry trend forecasting. No filler content whatsoever. This is straight-up insider information for hardware engineers, procurement staff, product designers, and anyone working on semiconductors, connectivity systems, automotive electronics, and energy storage equipment. Let's start with a quick overview of what this year's exhibition is all about. This expo covers the entire hardware ecosystem from top to bottom. We're talking about core hardware components including power semiconductors, MCU motor control chips, protection components, and passive devices. It also covers PCB solutions, MEMS sensors, optocoupler isolation chips, analog power management units, as well as FPGA main control chips, relays, and discrete components. All of these hardware products serve new energy vehicles, energy storage systems, industrial automation, and robotics applications. If you look closely, the industry's upgrade direction is super clear right now. Everyone in this space is chasing automotive-grade reliability. Wide bandgap semiconductor upgrades, high reliability isolation protection, higher chip integration, device miniaturization, and fully packaged turnkey system solutions. Global industry leaders are doubling down on exclusive production processes and proprietary equipment to build higher technical barriers. Meanwhile, top Chinese manufacturers are closing the gap faster than anyone expected. They're no longer just matching basic product parameters. They're now running formal mass production and validating their tech in real-world scenarios. All right, let's kick things off with the world's top-tier brands. These are the companies that set the high-end technical standards for the entire hardware industry. I'll break down their real core strengths, their hidden manufacturing barriers, and why they've maintained their dominance in the high-end hardware market for so many years. The 10 key players you need to keep on your radar are ADI, Molex, Hirose, TE, Amphenol, NXP, Infineon, Aptiv, onsemi, and TDK. These brands basically define the global technical ceiling for high-end hardware. And here's the honest truth: they don't win the market just because their product specs are better. They win because of exclusive manufacturing equipment, decades of mature proprietary processes, and long-term verified reliability systems that are extremely hard to replicate. First up, ADI. If you've worked with analog semiconductors before, you already know ADI is the absolute gold standard in this field. At this year's Expo, ADI showcased its full-stack analog solution, which integrates sensing, signal conversion, power management, and isolation into one complete, self-consistent ecosystem. Their new 2026 analog front-end chips boost overall accuracy by 15%. The ultra-low temperature drift is locked at plus or minus 0.5 parts per million per degree Celsius. This chip maintains exceptional stability across a wide temperature range, from minus 40 degrees Celsius to 125 degrees Celsius. It works reliably even in harsh automotive and industrial operating environments. For AI computing applications, their dedicated DC-DC power solution reaches a peak efficiency of 98.2%. That cuts down idle power loss and heat generation significantly for high-density server clusters. On the manufacturing side, ADI uses exclusive thin film deposition and laser trimming processes, paired with wafer-level precision calibration. This delivers outstanding batch consistency across mass production runs. And that's the key barrier most competitors simply can't break through anytime soon. Next, let's talk about Molex. When it comes to high-speed interconnect systems for AI servers and automotive hardware, Molex's leading position is basically unshakable right now. Molex is fully focusing on 4 high-value tracks: AI computing, energy storage, automotive electronics, and robotics. Their sidewise high-voltage connector supports 1,500 volts and 80 amps of steady current transmission, which fits photovoltaic and energy storage system needs perfectly. For automotive scenarios, their CMC and COMEX hybrid connector series fully covers both high-voltage and low-voltage vehicle electrical platforms. On the computing side, their Mirror MES ultra-high-density board-to-board lineup and NextStream high-speed technology enable extreme server miniaturization. Their MX-modular design merges power delivery, signal transmission, and high-speed data transfer into a single unified interface. This greatly simplifies the overall system architecture for hardware developers and shortens design cycles. In terms of manufacturing capability, Molex adopts micron-level high-speed stamping, ultra-precision injection molding, and real-time impedance testing throughout production. They keep production tolerance within plus or minus 2 microns. This is exactly why their 224 gigabits high-speed products maintain ultra-low signal loss, even during large-scale mass production. Moving on to Hirose. What truly makes Hirose stand out is its ultra-precision, highly durable connectors built for industrial and high-end automotive equipment. Hirose's core advantages lie in extreme miniaturization, strong shock resistance, and excellent high-voltage endurance. Their Z150 HV automotive connector supports 3,000 volts of withstand voltage and stable operation at 125 degrees Celsius. It fully passes the strictest automotive vibration and impact reliability tests in the industry. For industrial robotics, their FX31 floating board-to-board connector supports 25 amps of high current per pin. Its 3-axis floating structure offsets assembly deviation automatically, keeping stable performance even under long-term high-vibration working conditions. Their 9 industrial Ethernet connector supports Cat6, a high-speed transmission, fully compatible with next-generation PCIe Gen 6 and COM-HPC computing standards. Hirose owns exclusive ultra-fine terminal stamping and vacuum injection molding equipment. This allows them to mass-produce 0.3 mm ultra-narrow pitch connectors with stable yield. Their automated temperature cycling and vibration aging system simulates millions of working cycles, guaranteeing industry-leading long-term product reliability. Now let's look at TE Connectivity. They've made really impressive progress this year, with lightweight interconnect solutions and brand-new automated welding technology, which completely upgrades traditional vehicle wiring systems. TE's biggest highlight in 2026 is their full aluminum copper replacement ecosystem. Their CSG, H.V.0280, and H.V.0630 high-voltage connectors adopt professional aluminum welding structures. This cuts copper usage in vehicles by anywhere from 18% to 100% on different electrical loops, effectively reducing overall vehicle weight and manufacturing costs. They're also expanding their layout in humanoid robot micro-interconnects, megawatt-level fast-charging sockets, and industrial FPC wiring solutions. On the production floor, TE's fully automatic ultrasonic aluminum welder finishes each welding process in under 1 second, enabling large-scale production of lightweight vehicle wiring systems. On top of that, their exclusive anti-corrosion process solves the long-standing oxidation pain point that has troubled aluminum wiring systems for years. Next up is Amphenol. To put it simply, they dominate the entire high-speed liquid-cooled interconnect market for AI servers. No other brand comes close right now. Amphenol is the undisputed leader in high-end computing interconnects. Their brand-new XA-Max2 connector is custom-built for AI server liquid cooling scenarios. It solves the heat dissipation bottleneck for high-power optical modules and delivers stable signal transmission at 112 gigabits and 224 gigabits ultra-high speed rates. Their upcoming ZetaMax next-generation platform integrates bus-per-bus systems and SU power connectors together. It achieves all-in-one integration of signal transmission, power delivery, and heat dissipation for high-density computing hardware, with a daily mass production capacity of millions of units. In terms of manufacturing, their self-developed liquid-cooled packaging process and high-speed differential impedance testing system precisely control high-frequency signal loss. Their automatic high-precision cavity processing and gold plating equipment ensure extremely stable and consistent batch quality for high-end computing hardware. Up next is NXP. They're leading the core iteration trend for modern automotive-grade chip platforms, especially for software-defined vehicles. NXP continues to dominate the software-defined vehicle track. Their new generation automotive domain control chips deliver 20% higher computing power, while cutting power consumption by 12%. This matches perfectly with the central computing architecture trend for smart vehicles. Their gigabit automotive Ethernet chips provide ultra-low latency high-speed transmission. Their industrial MCUs feature upgraded EMC anti-interference performance and built-in hardware encryption. Backed by mature multi-chip packaging technology and professional automotive aging test lines, all their products meet the strictest AEC Q100 standard, the top-tier reliability specification for automotive-grade chips, ensuring long-term stability in complex vehicle operating environments. Moving to Infineon. Honestly speaking, they still set the global benchmark for wide bandgap semiconductor performance and mass production capability. Infineon remains the industry standard for silicon carbide and gallium nitride technologies. At this exhibition, they launched an 18 kilowatts three-phase power solution for AI servers. It adopts a 5-level ANC topology, a specialized circuit structure that greatly improves power supply efficiency, paired with gallium nitride synchronous rectification, achieving industry-leading energy efficiency performance. Their product lineup covers 77 GHz automotive radar, 48 volts low-voltage DC-DC modules, and silicon carbide solid-state circuit breakers for energy storage systems. Technically, they master the full industrial chain of silicon carbide epitaxial growth, wafer thinning, and lossless cutting. Their self-developed defect detection system keeps the mass production yield of silicon carbide products above 92%, setting the global manufacturing standard for wide bandgap devices. Let's talk about Aptiv next. If you're looking for mature, reliable high-voltage fast charging systems for electric vehicles, Aptiv is the undisputed industry benchmark. Aptiv's 800 volts high-voltage solution is fully ready for large-scale mass production. Their 1.32 megawatts liquid-cooled charging socket improves heat dissipation efficiency by 65%, supporting a full vehicle fast charge in just 7 minutes. This solution has already been deployed in mass-produced electric vehicle models. Their all-solid-state electronic fuse power unit reaches a SIL-D level, which is the highest automotive functional safety standard available, and supports over-the-air remote upgrades. Their HSCA automotive optical fiber connector breaks the traditional bandwidth limitations of copper cables, with fully automatic modular assembly and precision optical calibration. Aptiv's automated production level is far ahead of the industry average. After Aptiv, we have onsemi. They're extremely mature when it comes to mass-producing vehicle-grade silicon carbide devices, and their yield rate is truly impressive. onsemi's 2026 Ep.02 series includes 650 volts and 950 volts automotive-grade MOSFETs, adopting T2 pack top-cooled packaging. Compared with traditional silicon-based devices, their switching loss is reduced by more than 30%. This greatly improves power density for 800 volts vehicle platforms and high-power industrial inverters. They own mature large-scale vehicle-grade silicon carbide production lines, equipped with integrated high-voltage dynamic testing and heat dissipation packaging equipment. Their batch yield and extreme condition reliability are firmly ranked in the global first tier. Last but not least among global giants is TDK. Their exclusive material formulas and proprietary processing technologies for passive components create extremely high barriers that are hard for competitors to break. TDK's updated X2 series thin-film capacitors, high-frequency inductors, and chip capacitors feature miniaturized size, strong high-voltage resistance, and low power loss. They fit perfectly into high-precision computing, automotive, and industrial scenarios. Their core competitiveness comes from self-developed material formulas and exclusive manufacturing processes. Custom ceramic coating, thin film winding, and high-frequency loss calibration equipment deliver excellent product consistency, temperature stability, and anti-interference performance. These passive components form the underlying reliability foundation for all high-end hardware systems. Alright, we've finished breaking down all the top global brands. Now let's get into the surprising part, the eye-opening breakthroughs from top Chinese manufacturers that this Expo fully revealed. After analyzing the international leaders, let's switch gears and take a close look at the current technical strength of top-tier Chinese manufacturers. This year, their product coverage is incredibly comprehensive. Its product lineup covers core semiconductor and hardware components, including power semiconductors, motor control MCUs, circuit protection devices, and passive components. It also includes professional supporting solutions such as PCB designs, MEMS sensors, optocoupler isolation chips, analog power management chips, FPGA main control chips, and full relay systems. Simply put, they've built a fully closed-loop hardware technical chain from start to finish. It covers signal perception, main control computing, power drive, electrical isolation, power conversion, circuit protection, passive components, all the way to PCB carrier boards. Their upgrade direction is crystal clear, scaling up vehicle-grade reliability commercialization, advancing wide bandgap semiconductor research, building standardized multi-level protection architectures, improving chip integration and miniaturization, and delivering complete turnkey industry solutions. Of course, there are still obvious gaps to address. Most of their high-end wide bandgap products are still in research and sample testing stages, without formal large-scale mass production. They also lag behind top international brands in high-end high-frequency passive components and radio frequency core technologies. First, let's start with their core foundation: power semiconductors and motor control chip systems. Leading Chinese manufacturers have built a complete three-tier technical system. They have mature mass-produced silicon-based MOS devices, forward-looking research on silicon carbide wide bandgap semiconductors, and highly integrated vehicle-grade motor control chips. For silicon-based MOS products, their mainstream processes include planar, trench, and superjunction technologies. They offer more than 20 package types, covering SOT to DFN and TOL formats to support full scenario applications. Their vehicle grade series supports high current from 60 amps to 300 amps and ultra-wide temperature operation. Adopting MOS parallel topology, it adapts perfectly to vehicle motors, automotive lighting, and onboard charging scenarios, and has passed AEC Q100 verification from multiple mainstream vehicle manufacturers. For consumer and industrial scenarios, their products stably support 30 watts to 100 watts PD fast charging, Belt-C power tool drives, and customized constant power solutions for consumer devices, effectively solving common pain points like dry burning and power fluctuation. In terms of wide bandgap layout, major Chinese manufacturers have fully deployed silicon carbide, gallium nitride, IGBT, and silicon carbide diode technologies. The entire technical framework is fully completed and currently undergoing iterative sample verification. This will be their core breakthrough direction for high-end power devices over the next 1 to 2 years. In the vehicle-grade silicon carbide segment, they've launched 650 volts and 1200 volt silicon carbide Schottky diodes. These devices feature zero reverse recovery and stable high-temperature resistance up to 175 degrees Celsius, perfectly matching PFAC and LLC high-frequency power topologies. Their 80 to 100 volts vehicle-grade MOS adopts wettable flank packaging, supports AOE automatic optical inspection, and fully meets AEC Q101 vehicle-grade standards, matching vehicle-grade TVs, and can F low capacitance as protection ensures complete signal integrity for 8 megabits per second automotive bus communication. Best of all their power devices support 1-to-1 pin replacement with international mainstream models, allowing customers to switch suppliers quickly and conveniently. For motor control chips, they've formed a complete computing power gradient, They offer discrete MCU solutions, MCU plus pre-driver integrated solutions, and 3-in-1 solutions that combine MCU, pre-driver, and high-voltage power drive. Main frequency ranges from 100 MHz to 200 MHz, and high-end quad-core models support complex frequency conversion control algorithms. Peripherals are highly integrated with multi-channel PWM, ADC, CAN FD, and EtherCAT industrial high-speed buses specially optimized for BLDC variable frequency drive scenarios. Vehicle-grade models pass AEC Q100 Grade 1 certification, supporting ultra-wide temperature operation from -40 degrees Celsius to 150 degrees Celsius for automotive water pumps and cooling fans. On top of that, they provide complete model-based development systems, including schematics, PCB files, and full firmware resources, greatly lowering customers' research and development barriers. Next, let's talk about their full scenario circuit protection architecture. They've built a highly standardized, multi-level protection system that covers almost all industrial and consumer application scenarios. Chinese manufacturers have completed a full category standardized protection system, covering overcurrent protection, overvoltage protection, static protection, and lightning surge protection. Their product matrix includes fuses, PPTC resettable fuses, TVs, transient suppression diodes, TS's semiconductor discharge tubes, polymer S devices, and GDT gas discharge tubes. This achieves full dimensional circuit protection for both power loops and high-speed signal loops. In terms of certification, their product lineup has obtained UL certification, AEC Q101 and AEC Q200 vehicle grade certification, and full photovoltaic industry Ep.02 4819 qualification. The core architecture adopts classic hierarchical protection logic. GDT completes primary lightning discharge. TVs performs secondary voltage clamping. Polymer EST provides precise signal protection, and fuses deliver final overcurrent protection. This forms a complete closed-loop high-reliability protection system. Manufacturers clearly separate selection standards for power loops and high-speed signal loops. They've finalized mature standard topologies for BMS energy storage, new energy vehicle high and low voltage systems, USB-C and HDMI high-speed interfaces, home appliances, and industrial equipment. These ready-made solutions can be directly applied to mass production projects. Moving on to passive components, mainly aluminum electrolytic capacitors and MELC ceramic capacitors. This is another field where Chinese manufacturers have steadily narrowed the gap for industrial and vehicle-grade applications. On the capacitor track, Chinese manufacturers produce lead-type, patch, bolt-type aluminum electrolytic capacitors, polymer hybrid solid capacitors, and supercapacitors. The voltage coverage ranges from 6.3 volts to 800 volts, with service life spanning 1,000 hours to 20,000 hours, fully covering consumer, industrial, automotive, and energy storage scenarios. Their core process advantages include ultra-miniaturization design, ultra-wide temperature resistance from -55 degrees Celsius to 150 degrees Celsius, and modular integration technology. Some manufacturers independently develop upstream aluminum foil materials, achieving full supply chain autonomy. All products pass IATF 16949 and AEC Q200 vehicle grade certifications with full process MES traceability, meeting OEM vehicle material declaration standards for mass production. For MLCC ceramic capacitors, their material system covers mainstream types including COG, M3L, X7R, X5R, and X7S. Package sizes range from 00804 to 2020. Capacitance covers 0.1 picofarads to 220 microfarads, and withstand voltage spans 4 volts to 3,000 volts, covering almost all civilian, industrial, and vehicle-grade scenarios. Products are divided into general, industrial, and AEC Q200 vehicle-grade levels. Their customized soft terminal anti-bending series effectively solves PCB deformation and failure issues caused by long-term vehicle vibration. Production lines adopt 10,000 class dust-free automatic equipment, with a CNAS-certified laboratory currently under construction. Their products support precise one-to-one replacement with international first-tier brands. with very mature substitution capabilities. Next up is PCB Manufacturing Capability. Their specialized processes and vehicle-grade adaptation technology are far more advanced than most people realize. Chinese PCB manufacturers supply rigid boards, HDI high-density interconnection boards, flexible FPC, and rigid flex combined boards. Their maximum process capability reaches 78-layer rigid boards and 13-stage HDI, meeting mid to high-end industrial and vehicle-grade standards. In terms of specialized processes, thick copper, embedded copper, buried copper, and metal substrate technologies solve heat dissipation pain points for high-power automotive equipment and energy storage charging piles. The minimum line width and spacing of flexible FPC boards reaches 0.038 millimeters, meeting ultra-miniaturization and high-density wiring requirements. Their quality control system supports full process QR code traceability. The in-house reliability lab independently completes salt spray testing, thermal shock testing, ion pollution testing, and impedance precision testing. With IAT F16949 certification and National Green Factory qualifications, they fully support customized PCB solutions for automotive radar, BMS battery systems, vehicle domain control, and energy storage charging piles. One of the biggest highlights from this expo is their MEMS sensor technology. They now own independent in-house mass production lines with extremely high precision performance. This is a huge breakthrough this year. Leading Chinese manufacturers operate self-controlled 8-inch MEMS production lines. They independently complete dry deep silicon etching, piezoelectric thin film processing, and wafer-level welt bonding. They even provide external MEMS wafer foundry services, a very rare independent manufacturing capability in this industry. Their product lineup covers high-end motion sensing and force sensing devices. IMU gyroscopes come in consumer, industrial, vehicle-grade plastic packaging, and tactical-level ceramic packaging versions. Built-in Kalman filtering and MHE attitude-solving algorithms ensure stable output performance. Impact resistance reaches 10,000 grams. Working temperature ranges from -40 degrees Celsius to 85 degrees Celsius. And mainstream models pass AEC Q100 vehicle certification. Their 6-axis force sensor delivers 0.1% full-scale high precision, supports 150% overload protection and IP67 waterproof and dustproof rating. Perfect for robot tactile sensing and industrial precision detection. The product matrix also includes MEMS pressure sensors, UAV flight control modules, and wearable 9-axis motion tracking modules, with complete calibration and mass production reliability testing systems. Next up is their Optocoupler isolation product lineup. Honestly, they have one of the most complete isolation device portfolios in the entire industry right now. Chinese manufacturers have achieved full category optocoupler coverage. Their lineup covers mainstream optocoupler products, including transistor optocouplers, Darlington optocouplers, optical relays, thyristor optocouplers, high-speed and gate drive optocouplers. It also includes intelligent gate drives, IPM interface optocouplers, isolated operational amplifiers, and slot photoelectric switches to meet diverse application needs. Isolation voltage ranges from 3,750 volts to 7,500 volts across multiple specifications, with a wide working temperature range from -55 degrees Celsius to 125 degrees Celsius. Package types cover the full series of DIP, SOP, WSDIP, and LSOP. Production lines pass IAT F16949 certification, and multiple models obtain AEC Q101 vehicle grade certification, focusing on BMS battery management and automotive power drive scenarios. They've also built a complete engineer-friendly selection system. Every device comes with working principle explanations, typical application circuits, and full parameter manuals, greatly lowering the design difficulty for isolated circuits. Let's switch over to automotive analog chips. Their power management and signal chain solutions are highly optimized for modern vehicle operating scenarios. Local analog chip manufacturers focus heavily on automotive applications, covering intelligent cockpit and vehicle body domain systems. Their product matrix covers core power management chips, including multi-gear LDO, buck or boost DC-DC, multi-channel LED vehicle light drivers, high-side switches, electronic fuses, and load switches. It also includes ideal diodes, I/O expansion chips, precision operational amplifiers, analog switches, and level converters to meet diverse vehicle electronic needs. This achieves full coverage of automotive power and signal links. These products follow a three-stage development cycle. They include mature mass production models, ongoing iterative versions, and pre-research solutions for 800 volts high-voltage platforms. This design perfectly keeps up with the upgrading pace of automotive electronics. For 12 volts vehicle scenarios, they complete targeted ME electromagnetic compatibility optimization, surge suppression, and EST reinforcement, adapting to complex vehicle electromagnetic interference environments. On top of that, they offer powerful main control chips, FPGAs, DSPs, and fully matched vehicle-grade signal chain solutions for industrial and automotive projects. Their main control computing system covers industrial and vehicle-grade high-reliability scenarios. It includes 32-bit vehicle-grade MCUs compatible with international mainstream ecosystems, FPGAs ranging from 50,000 to 700,000 logic units, heterogeneous SoCs, DSPs, and AI SoC graphics processors. These devices meet industrial control logic, high-speed computing, machine vision, and lightweight AI computing needs. The signal chain is fully equipped with high-precision ADC-DAC, precision operational amplifiers, digital potentiometers, TEC temperature control chips, clock synthesizers, LVDT displacement signal conditioning chips, and Hall angle sensors, realizing closed-loop signal perception, acquisition, conditioning, and operation. The communication interface layer fully covers CAN/EFT, LIN, FlexRay automotive buses, 485 422 industrial buses, Gigabit Ethernet PHY, LVDS, and optical fiber transceivers, matching all mainstream high-speed communication architectures on the market. In terms of vehicle-grade core strength, their self-developed BMS-FE battery sampling chip supports 18-string high-precision battery collection, reaching the highest ASIL-D automotive safety level. The complete supporting set of vehicle-grade MCUs, bus chips, and power supply chips realizes full-link independent control of vehicle electronic systems. Meanwhile, they've accumulated more than 40 mature industry reference designs covering BMS, charging piles, servo drives, and machine vision, enabling rapid mass production for terminal customers. We also can't overlook their discrete devices and relay products. They've built complete supporting systems for industrial automation, energy storage, and new energy projects. Chinese manufacturers supply full-category discrete devices, including rectifier bridges, diodes, power MOS tubes, Hall devices, and optocouplers. They also offer agency services for high-end passive components to enrich customer supply chain options. Their relay product line forms a complete gradient layout, including signal relays, small and medium power AC relays, and high-voltage DC arc extinguishing relays. These products are specially optimized for photovoltaic inverters, energy storage systems, and electric vehicle charging pile high-current scenarios. Their overall business model combines discrete devices with systematic topology solutions. They provide complete device packaging solutions for photovoltaic inverters, charging piles, building automation, and factory automation, delivering one-stop supporting services for single industry scenarios. All right, let's wrap up this section with a quick and clear tech summary. Judging from this Expo's overall performance, leading Chinese manufacturers have completed a full closed-loop hardware industrial chain. From bottom-layer PCB carriers, passive components, protection and isolation devices, to MEMS perception units, analog signal chains, MCU and FPGA main control chips, and power drive semiconductors, every core link has independent domestic technical coverage. They can independently build complete hardware systems for new energy vehicles, energy storage, industrial control, and robotics. Current core technical hotspots are highly concentrated. Vehicle-grade reliability systems are fully landing in mass production. Wide bandgap semiconductor pre-research is fully completed. Chip integration continues to improve, multi-level circuit protection architectures are fully standardized. Independent MEMS mass production lines are mature, and turnkey industry solutions are widely adopted, greatly shortening customer research and development cycles. At the same time, structural shortcomings remain obvious. High-end silicon carbide and gallium nitride wide bandgap products still lack large-scale mass production capacity. And there are clear technical gaps in high-end high-frequency MLCC and radio frequency devices. These will be the core breakthrough directions for domestic manufacturers over the next 1 to 2 years. Now that we've covered all the on-site technical details, let's look ahead. I'll break down the 1 to 2 year iteration rhythm and future trends of the entire electronics and semiconductor industry, combining the technical layout, capacity expansion, and equipment iteration rhythm of global giants and Chinese manufacturers showcased at this Expo. The industry will enter a fast iterative, layered competitive cycle from 2026 to 2027. Let's start with the iteration speed of every core track. First is the AI high-speed interconnect track, the fastest updating field of all, with only a 6 to 12 month iteration cycle. Over the next year, 112 gigabits high-speed interconnect technology will be fully popularized, and 224 gigabits products will move from sample testing to formal mass production. Liquid-cooled integrated connectors will become standard equipment for data center server rooms. International giants will continue iterating 448 gigabits forward-looking technology, while Chinese manufacturers will focus on achieving stable mass production breakthroughs for 224 gigabits products. Second is the automotive high-voltage electrification track, with a steady 12 to 18-month iteration cycle. The 800 volts high-voltage vehicle architecture will keep penetrating the market rapidly. Aluminum copper lightweight wiring and silicon carbide high-voltage power devices will become new industry standards for vehicles. 1,500 volts high-voltage platforms will gradually land in mass production, and vehicle fast-charging power will continue to rise. Intelligent electronic fuse-powered distribution and vehicle optical fiber interconnects will gradually replace traditional copper cable systems. Third is the wide bandgap semiconductor track, with a rapid 12-month process iteration cycle. From 2026 to 2027, silicon carbide device costs will drop 20% to 30% year-on-year. 8-inch production lines will gradually replace traditional 6-inch lines. The yield rate of domestic silicon carbide products will steadily catch up with international levels. Gallium nitride devices will be widely applied in medium and high-voltage power scenarios, gradually replacing traditional silicon-based devices in mainstream applications. Fourth is the industrial precision interconnect and analog chip track, with a slow and steady 18 to 24-month iteration cycle. High-precision analog chips and high-reliability industrial interconnects mainly optimize product stability and consistency with mild technical upgrades. International giants' technical barriers remain stable, while Chinese manufacturers achieve continuous market breakthroughs through scenario-based customization and cost-performance advantages. From these iteration rules, we can summarize 4 core industry trends that will dominate the market over the next 2 years. Every hardware practitioner needs to keep these in mind. Trend 1, the layered competition pattern is fully solidified. High-end and mid to low-end market tracks are completely separated. Top international giants will continue to monopolize high-barrier markets, including 224 gigabits ultra-high-density computing interconnects, 3,000 volts high-voltage automotive devices, high-end industrial analog chips, and top-tier vehicle-grade silicon carbide products. They rely on process equipment barriers and decades of accumulated reliability data to maintain high product premiums. Chinese manufacturers focus on mid-end computing equipment, vehicle mass production projects, and general industrial control scenarios, seizing market share through cost advantages and fast iteration, while gradually penetrating high-end segmented tracks. Trend 2, equipment and process independence become the core determinant of competition. In the past, industry competition focused on product parameter matching. But moving forward, competition will center on back-end production equipment, core manufacturing processes, and exclusive material formulas. Leading manufacturers will keep investing in independent research and development of precision stamping, wafer growth, coating calibration, and automatic packaging equipment. breaking overseas equipment monopolies and upgrading from simple product substitution to full industrial chain independence. Trend 3. Turnkey scenario solutions replace single device competition. Both international giants and domestic manufacturers are phasing out the traditional single component sales model. Future competition focuses on integrated solutions that combine devices, processes, production equipment, and debugging services. High-end computing, automotive electronics, energy storage, and robotics will be the four core competitive battlefields. Integrated solution capability will directly determine a brand's market competitiveness. Trend 4. Lightweight design, high energy efficiency, and high reliability become rigid industry indicators. Vehicle aluminum copper replacement, equipment miniaturization, low device power loss, and high system reliability will be the core iteration direction for all hardware products. Energy efficiency improvement, weight reduction, cost optimization, and extreme environmental adaptability will replace simple parameter upgrades as the core product competitiveness. Alright, let's wrap up with my final takeaways from this 2026 Global Electronics Expo. To sum it up, this exhibition fully reveals the real competitive landscape of the global hardware industry. International giants' core moat is never just better product parameters. It's the systematic technical barriers built by exclusive production equipment, proprietary processes, self-developed materials, long-term reliability verification, and complete solution service capabilities. Leading Chinese manufacturers have achieved full category technical closed loop coverage of the entire hardware industrial chain. Right now, they're steadily breaking through manufacturing process barriers and high-end wide bandgap mass production limitations, already reaching internationally comparable strength in multiple segmented fields. That's all the pure technical content from the 2026 Global Electronics Expo. We've covered every technical detail, process capability, product iteration logic, vehicle grade certification standard, wide bandgap layout, and industry trend across all core exhibitors. This is 100% hardcore engineering analysis, with no commercial hype or filler content. But here's the thing most engineers and procurement buyers actually care about. Understanding the technology is one thing. Knowing what products are worth purchasing and deploying is another. In our next episode, the exclusive commercial and procurement chapter, we'll put aside all technical theories completely. I'll break down exactly which brands are worth sourcing, which products are worth stocking in bulk, which models deliver the best cost performance, which manufacturers have stable mass production capacity, and which options you need to avoid for your projects. We'll talk about real purchasing logic, batch stability judgment standards, product substitution grading, and practical supply chain advice for factories, purchasers, and hardware developers. If you don't want to miss this practical, cost-saving procurement guide, hit subscribe and turn on notification reminders. The next video is the must-watch supply chain tutorial for every hardware industry practitioner.